What's up, Algebra 1? So we just started topic 2 in module 2, and this is all about solving equations. So we talked about when something has one solution versus infinitely many solutions or even no solution. So let's jump into it. So this very first section has several different ones. They want you to write the properties that justify each method. So I'm going to start on this page, and I'm going to do A and C and let you try the other ones independently. So the first thing I notice is 3x and 7x are like terms, but they're on opposite sides. So I'm going to use the addition property of equality to add 7x away from the right side onto the left side for a new number. I'm then going to rewrite the rest of it. And I'm actually going to use the same property here because I want to put like terms of 8 and 18 together. It's currently subtracting, so I'm going to use the addition property of equality to add that value over to get 26, and then divide by 10 using the division property of equality to get 2.6. Let's check out a slightly longer problem that has fractions as well as variables on both sides with distribution. So let's start with distribution. First thing is to use the distributive property to multiply 1/2 times -10, it's -5x, and 1/2 times 4, half of 4 would be 2. And then I'm just going to keep on the right side distributing. -4 multiplied -3 would be 12. -4 multiplied 2x would be -8x, and then I'll also have plus 8. So now I'm going to use what's called the commutative property to change the order of the right side so that I could think about 12 and 8 going together. And so that would give us the same on the left. But now if I add 12 and 8 together, the right side becomes plus 20. Well, now I'm going to start doing kind of like what I did on A, combining like terms on the opposite sides of the equal sign. I'm going to start by changing the -8x to plus 8x, and that is the addition property of equality. I can add to both sides evenly, so that gives me 3x plus 2 equals 20. And now, for the first time I think that we've used in this exercise, we're going to use the subtraction property of equality to put 2 and 20 together. So that would be 3x equals 18. And then the very last step is the opposite of multiplication, is using the division property of equality to get x equals 6. So try those with the other problems. Did not do B, D, or E. So give those a shot and we'll check your work in class. Let's go to number 2. Move my face out of the way over here. It says determine whether each equation has one solution, infinitely many, or no solution. So let's look at the first one. If I think about distributing here, -2x and negative times a positive, that would be -10. And then on the right side, -6x is the first thing I have, but now I want to distribute 4 times x, 4x, and 4 times -2, -8. I now notice that I have similar like terms that can go together on the right side of the equation. So I'm going to say -6 plus 4 is -2x, and then subtract 8. Now, this is a key moment in the problem where we can now kind of stop and determine what type of solutions we have. Is it one? Is it none? Is it infinitely many? And so because these right here, these two numbers have the same coefficient of x, that tells me that it is not going to have one solution. In fact, if I go to put these together by using the addition property of equality, they cancel out completely because they're the same on both sides. However, -10 does not equal -8. It's not true. So that means this is no solution. So, whenever you have the same coefficient of x on both sides, the other numbers really tell you whether it's no solution or infinitely many. Okay? Let's look at f for a moment. If I was to distribute in f, you get 6x minus 6 plus 21. And then if you notice, I can put like terms together on the left side. -6 plus 21 is 15. So now, just like in the first case, we're in a situation where these terms match. 6x is the same on both sides. So now we can just go ahead and jump to the idea that if you were to cancel these out, you are left with 15 equals 15. Now, the first one, those numbers weren't the same, but this is a true statement. And that's true always, or forever, infinitely. So that is infinitely many solutions. Try the other ones on your own. Again, remember the answer is either one solution, infinitely many, or no solution. Let's look at this stretch for a moment. It says, consider this equation, solve for x. So let's start by distributing. That gives you -5x plus 5. Really watch your signs because that's often a reason why students make easy mistakes. 2 minus 5, over here on the left, we have like terms. 2 minus 5 is -3x. And so we're going to keep on trying to get x by itself. Use the subtraction property of equality to subtract 5 from both sides. And then let's divide by -3 to get -15. So the second part says that Chen asked to solve this equation, this inequality, and we haven't really talked too much about that. That's what the next chapter is going to be. But it looks like they changed from an equation using an equal sign, and they're now using a less than 50. So it says substitute any value for x that's less than -15, and if you remember, that was the exact solution. Determine if the solution is correct or not. So this right here is numbers less than -15. So maybe like -10, -20. Sorry, -20. -20 is less than -15. So let's jump into the problem, and basically let's plug in our solution of saying -20 just to see what would happen. So 2 times x, -20, minus 5 times x minus 1, -20 minus 1. Does that come out to be less than 50? And in college, we put a little question mark here because we're not sure if that's true yet. So that allows us to kind of remember what the point of the problem is. So let's just see what we get. 2 times -20, -40. If you put these together, that would be -21. And if you were to distribute -5 to -21, that gives you positive 105. So now, when I go about solving this, -40 plus 105, that would end up being 65. Now, is 65 less than 50? No. So that is not true. You don't get to just say it's less than that same value that would have been a solution. Okay. So let's talk about some review. This review is asking us to determine whether the table of values represents something that's linear. And if it is, try to write the function, like what the equation is. So I'm going to start by studying some behavior here. In the input side, they're all consistently adding 1. This one subtracted 3, then it subtracted 1, then it added 1. I do not believe this is linear. Not linear. If you were to graph these points, you'd see that change in the movement, making it not form a line. Nelson grows tomatoes and sells them at a nearby farmer's roadhouse stand. He sells them for $2.50 each. So that feels like that number could happen more than one time. It just depends on how many you buy. The farmer charges him a $15 a day use of the stand. This seems like it's a one-time fee. So write a linear function in factored form and in general form that represents how much money he's making. So the idea is that I am selling my tomatoes for $2.50 each. So if I want to sell one, it's $1. It's 1 times $2.50, which is $2.50. Or if I sell 2, well, $2.50 times 2 is $5. However, if I'm calculating my profit, how much money I make from the stand, well, I have to pay $15 to be out there. So I have to take $15 away from my profit to give to the man or woman who's selling me this stand or letting me use this stand for the day. So the idea of factored form is trying to kind of get down to the fact that, well, like, how many tomatoes is that? How many tomatoes do I have to sell to break even? To basically say I've paid for the stand before I start making any money. Well, we want to start by recognizing that 15 is divisible by 250, and that'd be 6. Essentially, I'd have to sell 6 tomatoes to break even. So I'm going to do what's called factor. I'm going to factor the 250 out of my expression, and that would leave me with t minus 6. If you were to distribute this, you would have the original function that we created. So this is your general form. This right here is your factored form. Okay? Factored form means it looks like distribution. It's a form of multiplication because it sits next to each other, like multiplication does. All right, number 3 says Clean Green Landscapers uses a graph to show what they charge, and Sunshine Landscapers lists what they want to charge in a table. So it says each representation shows a functional relationship between quantities, okay? So what I want to look at here, it says label the quantities and their units in the table and on the graph. So let's read it a few times. Clean Green Landscapers use a graph to show what they charge, and they list what they charge in the table, shows a functional relationship between quantities, label the quantities and their units in the table and on the graph. So it feels pretty open-ended, to be honest with you. Maybe this is hours worked. Maybe I'm working a landscaping job and I'm going to charge them based on how many hours the project takes. So maybe this over here is how much money I'm charging them. Same thing here. Maybe this is hours and this is money. Obviously, it seems to be money because they're using the dollar sign in their table. So now it says, let C of x represent the function for the table, and then let S of x represent the function for sorry, I said this backwards. Let this one represent the graph, and let this one represent the table. So it says which function has a steeper slope, and explain how you know. So let's look and see what some good points are here in the table. I see this point right here is pretty good. 2 hours is $90. Well, that tells me something. That basically tells me that it's $45 for only 1 hour. And you can actually see that 145 right here. So I'm going to do something similar over there. It looks like for half an hour, it was $25, but for 1 full hour, it was $50. And we can kind of see that that makes sense here because 2 hours is 100. So this is basically $50 per hour. And so now it says, well, which function has a steeper slope? I would say the table. The table has a steeper slope because 45 is less than 50. So 2 hours costs 100 in the table versus 2 hours costs 90 in the graph. That tells us that the rate of change is more. This is a more expensive landscaper on the right using the slope formula. All right, so we've been talking about evaluations. I want you to plug in -2 for everywhere that you see x and basically tell me what is that equation equal if x is -2. Last question, it basically gives us a function for how a company calculates the cost of installing so many air conditioners. And it also tells us that x represents how many you're installing. So just like the other one, plug in 45 and carefully calculate the answer. I hope this was helpful. Thanks for watching, and we'll see you next time.